Assalamu alaikum. Today we are going to start our lecture. The title of the lecture is Influence Lines for Shearing Force. So I'm going to share the lecture notes. So first of all, the sign convention for the shear force. Now, if you look at on the right side, this R stands for the right side portion of the beam and L stands for the left side portion of the beam. When the right portion of the beam to the section is going downward and left portion upward, this shows the adopted sign convention for positive shear force. Now the shear force is at the interface. When the right portion is going downward, the resisting force will be upward. Similarly, when the left portion is going upward, the resisting force at the interface at the section is downward. So the forces shown with red color, these are the shear force, positive shear forces. So second point is the shear force and bending moment in beams are defined at a particular sections. Now, computation of maximum shear force at a particular section for moving load is also based on same two steps. The step one is drawing of ILD for shear force at a particular section for unit moving load, and the step two is determination of critical location of actual moving loads either by trials or by judgment or by the combination of both, or lastly by using the mathematical criteria where it will give the maximum value of shear force and then computation of the maximum value of the maximum shear force. Now we will understand it with an example. Now consider this is simply supported beam and reaction RA at support A and reaction RB at support B. Now the shear force is required at section MN, which is at a distance A from the support A and at a distance small b from the support B. The span of the beam is L. So the first step is drawing of ILD for unit moving load. This unit moving load as shown, and for a specified time it is at a distance x from the support B. Now the simplest method is based on the influence line diagrams for the reactions RA and RB. Now when the unit moving load is on the right of the section like this, which has been shown. Now this right portion is going down. This right portion is going down. This corresponds to the positive shear force. Shear force is positive as per sign convention and equal to RA. We will consider the left portion going upward, positive and equal to RA. So now we will draw the ILD for RA as usual. This line RA, 0 at B and 1 at A. This is the influence line for RA. Then now when the unit moving load is on the right of the section. Now this load is on the right of the section. Now the left portion of the section, when the unit moving load is on the left of the section, this left portion is going down. And according to this sign convention, the shear force will be negative. And considering this right portion, and the shear force will be equal to RB. And this is from the basic definition of the shear force. So we will draw the ILD for RB as usual. Now 0 at A and 1 at B. This is a straight line. Now the or alternatively using the technique based on principle of virtual work, giving a unit positive displacement under the section. How much total is 1, but how much for each portion in the ratio of distances A and B. So this will be B over L and this is A over L. Total has to be 1. So 0 at the supports. So now marking these points and joining these points, the resulting shape will be, which has been shown by this shaded area and by the red color. So this slope is 1 over L. This is 1 over this ordinate for negative region A over L. This ordinate for positive region is B over L. So, or this much, this one, giving a unit positive displacement in the ratio of their distances. This ordinate is B over L, this is A over L. Total has to be 1. A over L plus B over L is equal to 1. Unit positive displacement. So this is again the ILD for shear force at section MN. So both these lines has to be parallel. Now considering A equal to 4 meter, A is 4 meter, B is equal to 14 meter, and this total L will be 4 plus 14, 18 meter. So we have to determine the maximum positive and negative shear force under the section. So keeping in view the guideline for maximum effect, it may be easily judged. Now these are the 3 wheels. Now it is very convenient to understand the positive shear force can be maximum when wheel 2 will be here, because when wheel 1 will be at the section, this smaller load, which is 4 times smaller, will be multiplied with this bigger ordinate. So that will not give the maximum positive shear force. So the judgment says the maximum positive shear force will occur when wheel 2 will be at the section. So this 64 will be multiplied with this B over L, 14 over 18, the respective ordinate for positive portion. Then wheel 3 is at a distance of 4 meter from wheel 2, so 64 into 10 by 18. So the total is 85.33 kilonewton. Similarly, the negative shear force, this portion, total is 4 meter. So again, the judgment plays the role when we will place wheel 3 at the section. So maximum negative shear force will occur. So this 64 will be multiplied with this respective ordinate of the negative region A over L. So 64 into 4 over 18, that is 14.21. Now, any question in this problem?
No, sir.
So compute the second problem is compute maximum positive and negative shear force at section Mn of the same beam for following moving load. Now, if you look at no span A has been specified for this UDL. It means it will be adjusted according to the situation. There are two possibilities, the UDL with specified span with UDL with unspecified span. Now again, the drawing of the ILD for shear force at section Mn is exactly the same, 14 over 18, 4 over 18. Now this wheel 1 in half of the wheel 2. Again, you can apply the judgment that maximum positive shear force will occur when wheel 2, this 40 kilonewton, will be at the section Mn. This arrangement, 40 here, then 20 again, negative region, and so on. Now, first is the area of ILD under UDL, half 8 into 8 by 18 into 16. That is the intensity of the UDL, plus 40 into 9.5 over 18, plus 40 into 11 over 18, plus 40 into 12.5 over 18, plus 40 into 14 over 18, minus, because this wheel 1 is in the negative region, so 20 into 2 by 18. So the maximum positive shear force is 130.66 kilonewton. Now similarly, the maximum negative shear force, now you can see that any wheel on the section will not give the maximum negative shear force. Yes, the UDL is to be placed in the negative region. By judgment, it is clear that the shear force will be maximum when UDL comes over this portion. So half into 4 over 40, 4 over 18, the area of ILD under UDL, into 16, the intensity of the UDL. This comes 7.11 kilonewton. Alternatively, you can make the trials if anyone is not able to apply the judgment. So the next is the mathematical criteria for the same problem. Now, if the trials or judgment or the combination of both is not working, then third option is to use the mathematical criteria. We compute the change in shear force associated with each advancement of the wheel load. The change in shear force is GA over L minus Pn. These are the same terms which we have used in case of ILD for reactions. Let's apply it for computing the maximum positive shear force for the above beam. So first advancement, wheel 1 is advanced from the section Mn and wheel 2 is now at the section. Now wheel 1 is also on the span. This is the arrangement. Now G is the sum of the loads, sum of the wheel loads and other moving load on the span. That is 20 plus 40 into 4 plus 16 into 8, that is the UDL. The total is 308 kilonewton, whereas A, the advancement distance is 2 meter. Now look at this, the distance between wheel 1 and wheel 2 is 2 meter. So Pn is the load which has been advanced, that is 20 kilonewton. Span is 18. So change in shear force GA over L is 308 into 2 over 18 minus Pn 20 plus 14.22 kilonewton. It is positive. As long as the shear force is positive, shear force will keep on increasing. The wheel which reverses this condition will give the maximum shear force when placed at the section. Now proceeding for the next advancement, wheel 2 is advanced and the wheel 3 is at the section MN. Now wheel 2 is advanced. So PN is 40. Advancement distance is 1.5 meter. A is 1.5. So wheel 3 is at the section. Now this 8 will be 9.5. So in this case, the load will be 20 plus 14 into 4 plus 16 into 9.5, 332 kilonewton. A is 1.5, L is 18 meter. Pn is now 40 kilonewton. Now change in shear force is 332 into 1.5 over 18 minus 40. That is negative now, minus 12.33. Thus, wheel 3 will not give the maximum positive shear force. It will be the wheel 2 when at section will give the maximum positive shear force, जो कि हमने भी कंप्यूट भी की है, क्योंकि व्हील 2 के जाने से ये कंडीशन रिवर्स हुई है. So mathematical criteria, no criteria is for simply supported beams. जी इसमें कोई आपकी कंफ्यूजन? So
No, sir.
we proceed for the overhang portion, overhang beam. Now for an overhang beam as shown, we have to compute maximum positive and negative shear force at a section 3 meter from support A for the following loading. This is loading A, comprising of 3 wheels of 20 kilonewton, 25 and 30 kilonewton at a distance of 2 meter each. Just a break of 1 minute. Yes. So these 3 wheels, they are comparable. Comparable, this is 20, 25 and 30. Whereas in earlier cases, the wheel 1 and 2 were not comparable. So the second loading is the UDL of not with unspecified span. Now the first step is drawing of ILD for unit moving load using the principle of virtual work, giving a unit positive displacement under the section and 0 at supports. Marking and joining these points with straight line will give the required ILD. Now this distance is 5, so 5 by 8, this is 3, 3 by 8, total has to be 1. So you will join this 0 and this 0 with these 2 points. So in overhang portion, this line will go straight in the overhang portion. So there are two negative portions and one positive portion. These are the slopes 1 by 8, 1 by 8 and 1 by 8. Now first of all we consider the loading A. This for positive shear force. So total span is 4 meter. So what the judgment says, now look at this loading and this positive region, 5 meter and 4 meter. So the judgment says that positive shear force at section MN will be maximum when wheel 1 is at the section, because wheel 1 and 2 they are comparable. However, if you are not able to apply the judgment, you can make the trials, wheel 1 at the section, wheel 2 at the section. So when wheel 1 is at the section, so 20 into 5 by 8 plus 25 into 3 by 8 plus 30 into 1 by 8. So the sum is 25.625. Alternatively, when we will make the trials, wheel 2 is at the section, so it will be 25 into 5 by 8, 30 into 3 by 8. So wheel 1 will be in the negative portion, so it will be subtracted. So minus 20 into 1 by 8, 24.375. It's close to the first value. So in this such situations, you can make the trials. So the conclusion is wheel 1 when at the section PQ will give the maximum positive shear force. Similarly, the negative, for negative shear force, this portion is 3 meter, this negative portion is 2 meter. So we will consider this portion. So we can say that again by the judgment, that negative shear force will be maximum when wheel 3 will be at the section, when wheel 3 will be multiplied with this ordinate of negative portion. So 30 into 3 by 8 plus 25 into 1 by 8, 14.375. Now loading B, this UDL for positive shear force, this portion is to be loaded. This portion is to be loaded because that is the positive portion. And for negative, the portion AD is to be loaded. For positive, portion DB is to be loaded with the UDL. For negative shear force, portion AD should be loaded with the UDL. So for positive, it comes out to be area of ILD half into base 5 into height 5 by 8 into 6. That is the intensity of the UDL. This comes out to be 9.375. For negative portion, portion AB, UDL over portion AD. So it will be half into 3 into 3 by 8 into 6, 3.75. जी इसमें कोई क्वेश्चन आपका? So I think no question.
Sir.
So at the end of this lecture, I will ask the questions. So this is a compound beam having two additional supports which have been compensated with the introduction of two hinges at point B and point E. So as far as the continuity of the function is concerned, we have three portions: portion AB, portion B, C, D, and E, and lastly the portion EF. Now it is required to compute the maximum positive and negative shear force at section MN, which is at a distance 2 meter from support C and 3 meter from support D. Now again, the theme is same. Now, first of all, look at this bottom diagram. We will give a unit positive displacement under the section and 0 at supports. So 0 at A, 0 at C, 0 at D, and 0 at F. And this is the unit displacement in the ratio of these distances 3 by 5 and 2 by 5. So this slope is 1 by 5, this slope is 1 by 5. Now from this diagram between point C, support C and D, we have to extend these lines as far as the continuity of the function is concerned. So on the right side, this line will go straight up to point E, up to hinge. Here, this will come here. Now it is 0 here, so these two points will be joined with the straight line. Similarly, on the left side, this line will go straight up to the hinge at point B. Then it is at 0 at A, so these 2 points will be joined with straight lines. These are the slopes 1 by 5. This is 1 by 5. This distance is 5 meter horizontal distance. So slope 1 by 5 into 5, 1. So this horizontal distance is 6 meter. So this ordinate is 1. So this slope is 1 by 6. So this ordinate is 2 by 5 and this horizontal distance is 5 meter. So this slope is this ordinate divided by this horizontal distance. So 2 by 25. So in this way, the influence line diagram for shear force at section MN will be drawn. Any question on it? Actually,
Sir, Philal,
the concept is same, except that in reactions you have to give a unit positive displacement in a different manner, unit positive displacement in shear force in a different manner according to their sign convention, and unit positive rotation in case of bending moment. Rest the procedure is same. Rest the procedure is same. So step 2, that we have to compute the maximum positive and negative shear force for standard truck loading. So this is the positive portion, this is the positive portion. So the judgment says that at least one wheel has to be at the section. So judgment says that the positive shear force will be maximum when wheel 3 is at the section. Now focus on this. When wheel 3 is at the section, so the maximum ordinate of this positive portion will be multiplied with the heavy wheel. Now the secondly, the same heavy wheel will be multiplied with this maximum ordinate. and the third wheel is again in positive region. Now here you have to apply the judgment based on common sense. अब इसके लिए कोई फार्मूला नहीं है. फार्मूला कंपाउंड बीम के लिए वो आपका मैथमेटिकल क्राइटेरिया नहीं चलेगा. यहाँ पे आपको ट्रायल्स और जजमेंट अप्लाई करनी है. अब यहाँ देखें कि व्हील 3 जब आप सेक्शन पे अप्लाई करेंगे, लगाएं, रखेंगे इसको, तो ये heavier wheel is bigger ordinate of this positive portion. This second wheel with this higher ordinate, and the third wheel is again in positive portion. However, अगर ये distances change हो जाएं, तो the situation will be different. Actually, you will make the practice by changing these horizontal distances. As much as you will do the practice, you will have the grip on these topics. So the maximum positive shear force will be 64 into 3 by 5 plus 64 into 2 by 5 plus 16 into 2 by 25. The answer is 65.28. Similarly, maximum negative shear force will occur when wheel 1 will be at the section MN. Now look at this. If we place wheel 1 at the section MN, so this wheel will be multiplied with this negative portion. Actually, this negative portion is very small as compared to this negative portion. Now, this ordinate is 2 by 5. This ordinate is 1. Much difference. So, when we will place wheel 3 at the section, wheel 2 will be in this negative portion. Wheel 3, both heavy wheel, will be in this bigger negative portion. So, this will be 16.2 by 5 plus 64 into 1 by 5 plus 64 into 1. That is 83.2 kilonewton. However, if it is difficult to make the judgment in first go, you can make the trials. वो trial भी एक line के हैं. That will not take much distance. Just you have to compute these ordinates. कि ये ordinate की value क्या है, and that is possible with the help of this slope and the horizontal distances. Now, for standard train loading, for maximum positive shear force, you have to try wheel 8 at section MN. For negative shear force, try wheel 1 at the section MN. Please do it yourself. जरा इसको करें अभी आप. अपने जरा कैमरास ऑन करें. Which book we can find this two lecture? The lecture as it is, you will not find. Actually, this is the extraction in a simplified version. However, the reference book is the Structural Analysis by R.C. Hibbeler.